ASU researchers have developed what is being described as a breakthrough diagnostic tool that could transform how reliable and quickly illnesses like COVID-19, Ebola, AIDS, and Lyme disease are detected. The device is known as NASRED, and to learn more, we welcome Chao Wang from ASU's Biodesign Center, I guess for molecular design and biomimetrics and bio. It's the design center, the Biodesign Center, doing great work over there, including this. They're calling this a breakthrough in diagnosing diseases. Talk to us about this.
Thank you for having me. So this breakthrough dated back to a couple of years ago during the COVID-19 pandemic. At that time, we were short of masks and we were short of tests. So at that time, I told my students, it's time for us to shine. We try to really work out a technology that eventually can save people's lives. But we were kind of late. Eventually, a couple months ago, we were able to finish the work, and this work has been featured in a journal, and this is a device that we have been working on. So it's a portable device, as you can see,
yes,
and can achieve detection of a very small amount of sample, as you can see from here.
I mean, those vials are tiny.
Those are tiny.
I mean, goodness gracious.
Yeah, these very tiny samples. What you can see at the bottom of the tube, just the volume of the sample is less than a drop of blood. When you finish a test, you put them here, then you collect electronic signals. And the whole test time can be finished within about 15 to 30 minutes. And the sensitivity is comparable to gold standard tests we are using right now in the lab, such as LabCorp or SNORACast.
Okay, so this is basically a blood test that has been streamlined to the point where 15 to 30 minutes later you can get it from a drop of blood. How does this work? Because I know, reading about this, you got like nanoplated particles that are gold, the gold-plated what's going on?
Yes, that's a very good question. I think that can be seen from here.
Yeah.
So that's a tube of nanoparticles, as you can see.
Yeah.
They're reddish.
Yes.
Guess how many are there?
I have no clue.
More than 10 billion nanoparticles in here. They are so tiny. Each of them is only about less than 100 nanometers, which is 1,000 times smaller than the diameter of human hair.
And so these, with the blood, you put the blood in there, and what, the nano things, they attract the, like if there's a COVID or there's an AIDS or there's a Lyme disease particle in there, they'll attract each other?
Exactly. So what happens is that we have one tube of the sample. We use, we call them sensor tube. Then we have another tube of human sample, like saliva or urine or blood or serum, even cerebrospinal fluid. You name it.
Yes.
So you mix them, you finish the procedure, you put them here, you can finish the detection. What happens is that the nanoparticles, they carry small molecule on the surface. They are small, but they are much bigger than protein. So each of them nanoparticles carry hundreds of these molecules. They're trying to grab the target proteins.
Yes. And if they grab one, you got to hit.
You got to hit, then you produce signal.
Yeah. This is going to be big stuff for rural areas, for smaller areas where it's difficult to get your blood tested. I would imagine in emerging countries, lower income countries and stuff like that. Is that where the target is here?
Exactly, that's my motivation. Actually, we want to make this accessible, not only sensitive, but also accessible. That means it needs to be portable, it needs to be rapid, it needs to be low cost. So we can achieve all of these. So that can be used, as you mentioned, in PCP office, in emergency rooms, even in the ambulance.
Right, right. Low cost, you mentioned that. How much training is needed to run these kinds of things?
So what we want to achieve eventually is you have a workstation, you turn the key on, you set up the protocol, eventually it can be automated. Yeah.
Oh, okay.
So we're not quite there yet, but I'm working in this direction.
Real quickly, because we got to get going here, but how long before you get there? How long before this is out there?
I would say probably 3 years. That's my
3
bet.
years still,
yeah.
Huh? Well, it's really exciting. I mean, that's amazing to have a blood test that would be as accurate or more so than a full-blown lab test in just that. That's good stuff.
Thank you. But that's basically research. That's what we're trying to do.
Yeah.
Research takes time, but I hope eventually research can make an impact to humans' lives.
Well, great work, Chao Wang. Again, congratulations on this, and I'm sure we'll be hearing more about this in the coming years. Congratulations, and thanks for sharing your story. We appreciate it.
Thank you, Ted, for having me.